Welcome to the PermafrostNet channel. In this video, we'll be exploring not just one, but two new research software tools built for the permafrost community. These tools are designed to streamline your workflow and boost efficiency. Our first software tool is called TSP, or Teaspoon. This piece of software harmonizes ground temperature data from different sources by offering a range of readers, but also provides data analysis and visualization capabilities, making it a great asset for permafrost scientists and engineers. We'll explore its intuitive interface, walk you through the essential features, and demonstrate how it can be used to streamline your work with ground temperature data, no matter where it's from. Once we've covered TSP in detail, we'll move on to our second software tool, tempcf. This utility is specifically tailored for visualization, quality control, and assessment of ground temperature data. It also demonstrates how TSP can be used to build reusable tools and workflows. Throughout the tutorial, I'll provide step-by-step instructions and highlight the capabilities of each software tool. By the end of this video, you'll have a solid understanding of how to leverage these tools effectively and take your research projects to the next level. Let's get started. I'm going to show you how to use TSP or Teaspoon, a Python package that's been designed to look at ground temperature data for permafrost. So I have Visual Studio Code running here. Any Python interpreter will work. And the first thing you need to do is install it. So you can install it with pip. Just type pip install TSP, and we'll just add this square brackets full, and that will make sure that all of the additional pieces get installed. And when you run that, there'll be some things that display here. I've already downloaded a lot of the requirements, and so this is maybe going a little bit quicker. But first time, it might have to download some extra things. Once that's done, we can check to make sure it's installed properly. Just import TSP, and no complaints, so it seems to have worked well. So the first thing we'll do is import the library of readers. So this is designed to be able to read data from a variety of different sources, data loggers, models, permafrost databases. So we'll just type from TSP import readers, and then we'll go ahead and start looking at some data. So I've got some sort of prepared here. And the first one that I'll look at is from the geotop model. So this is model output rather than observational data, but it provides a good way to sort of explore some of the features. So once that's read in, whatever variable you assign it to, if you can just put it in, you can have a look at it. So it'll show just a view of the data. And if you want to look at the timestamps, you can go times, it'll give you all the timestamps. Similarly, if you want to look at the depths or the values. And these can feed into other analyses. They're now standardized in this data structure in the program. If you want access to the data frame itself, it's a pandas data frame. There's two ways to look at it. One is looking at the so-called wide data. So here we have the depths across the top and the times down the side here. And so you can assign that to a variable and treat it like any other pandas data frame. And the other way you can look at it is the sort of long or tidy data. And in this, we have each row is an observation and each column is a variable. So you have the time, depth, the temperature in the ground, and how many observations that represents. And so obviously here it's 1, but if we do something like this, and we look at the annual averages or the yearly data, and that just gives you, every year the annual average if you're looking at something like mean annual ground temperature. And then if we look at the long or tidy format of that, you can see that the number of observations is increased in most years to 365, and in sort of the first year to not quite that many. There's not enough. This function and all the functions in here have help documentation with them. So we can just go ahead and look at the documentation for the yearly averaging. And you can see that there's a few additional parameters you can specify here. So if you want to have a minimum number of observations in your yearly average, a maximum gap in your data, or a minimum span in your data, you can put those in. And that just makes it so that you don't get skewed averages if you only have a few observations in a year. But anytime you're curious at finding out more information about a function in this package, you can just use the help function. You can also look at documentation online, permafrostnet.gitlab.io/teaspoon. Just pull that up here. And that has some examples if you're interested in contributing or citing the package, and then detailed documentation for all of the different readers. So if you're interested in seeing what all the different readers are for the package, you can look at that here as well. So next we'll look at a few of the other readers. So there's one for reading from the GTNP database. And so here it's a different structure for the data, but it all shows up in the same way in the package here. One other thing that can happen when you're reading this kind of data is sometimes you'll have duplicate timestamps. And so here, when you load this second file in, it says duplicate timestamps found, and then it gives you a list of all the timestamps that are duplicated. And so we can check this, 2 times. So looking at all of the times in the data set, and verifying whether any are duplicated, and we see that they are. And so this package Teaspoon has a utility to get rid of duplicate times, because sometimes you just need to delete them if you want to do any sort of simulation with the data, for instance, or converting it to other formats. So there's this function resolve duplicate times, and you can just take the first occurrence, the last occurrence. And so now when we rerun that same check to see if there's any duplicate timestamps, you can see that they've been cleared up. We can also read from data loggers. So here's something from a HoboWare. And for HoboWare, there's different ways of configuring the time format and the separator in the file, so it automatically detects how those are set up, and again gives us the 2 values. The other thing is that data loggers, unlike some of the results we get from models or databases, often don't have the true depth in the file. So what this does is it treats each depth as an index, so 1, 2, 3, 4, 5, and so on. And what you can do if you want to set the depths is just use this set depths function. We'll say that these are at 5 and 10 centimeters. And now you can see that those depths have been assigned to the data. And you can also look here. It's now 0.5 and 1. So that's reading the data in. Now you might want to plot it. So I think we'll go back to our model data because it'll give us the nicest plots for now. Easiest way to do it is just you have this Teaspoon TSP object and use the method plot time series like I just showed you, and you'll get this very standard time series plot. And this can be helpful if you're wanting to just read some data in either from a model output or something you've downloaded from the field, and just have a look and see if it makes sense. Look at any anomalies. It's not necessarily designed for publication-ready figures, but often just being able to check the data efficiently without rewriting scripts, depending on what your data looks like, is pretty handy. And so you can turn off the depths here if there's a particular one you want to look at. The other thing to note here is that if you want to modify the figure for any reason, this function does return a figure object. So if you just assign this to a variable, go back, you can run operations on that figure. So here we're going to get a property of that figure and add a horizontal line at 0 degrees. And then the next time we update the plot, you can see that this is a 0 degree line added. So if you want to do anything fancy, you can always modify the figure directly. Some other kinds of plots that are built in here is just a simple trumpet curve. And again, this isn't necessarily for a publication, but if you're just looking through your data and you want to make sure it's good, this is the perfect sort of tool. So plot trumpet, you give it the year, and you can control the maximum depth as well if you'd like. And then the last one that's in there right now is a contour plot. And so these parameters, again, you can look up on the documentation. You can do help to plot contour to see what the parameters are. And in fact, here, this uses a different function to run the plots. And so you would actually look at in TSP plots, and it gives you all the information about the color contour plots. But here we're saying it plot the contour at 0 degrees, label it, and only go to 12.5 meters. And so you can see here it's the same time series data, but we have the 0 degree isotherms every year and the 0 degree isotherm depth. So like I said, when you read the data in, you get this object. And if you ask, it's a TSP, capital TSP object. If you have your own data that you want to just use the plotting functionality that's in the package, you can do that as well. And so to do that, use the tsp.plots module. So from tsp.plots, import time series. And there's a few others you can look at again, just look in the documentation. Yeah, as I said, help time series, and that will give you the help. So you give it the depths times the values. You can give it a title. So now you've looked at the data, maybe you've read in a data logger or something from a model and you want to write it into a different format. So you might want to write it in the GTNP database format if you're submitting your data there. So all of the TSP objects have this to GTNP, to JSON, to .NET-CDF. We'll write it to GTNP and then just give it a file name. And then we can maybe have a look at that there. So it's been converted into the GTNP style format. So if you have any existing scripts or functions that require that, it's easy to convert in between different formats. If you have any other questions about the package, you can look on this site, gitlab.com/permafrostnet/teaspoon, and this is the code repository, and that can direct you to the other documentation here. Just open it up. So if you want to contribute, you're welcome to do that. If you're interested in using the package in your research and you're interested in citing it, there's a journal article here If you're interested in receiving updates, just star the repository, and scrolling down, you can access the read the docs pages too if you want some more examples, more information on how to install it, and a list of all the different functions. Okay, in this next part of the video, I'm going to show you another tool called tempcf, and it's a visual ground temperature cleaning tool that uses Teaspoon TSP library to read and write ground temperature data files, and provides an easy way to clean the data using a number of filters or just manually selecting data that is obviously sensor dropouts. So again, the first thing you need to do is to install the software. So from the command line, if you have Python installed, just type in pip install tempcf, and should successfully install. To check that it has, you can just run the program by typing in tempcf into the command line, and after a few seconds it should open up a window. And under the help menu, there's a demo data set that we can use just to do some preliminary exploration of some of the features. So there's a window with the data plotted here. It's just a single depth. You can pan the data around, you can zoom in, go home. For viewing under depths, you can, here there's only one depth. Yeah, nothing else. You just turn it on, turn it off. Then here you can see that the data changes from when the instrument was, before it was installed. Here is quite warm temperatures, and then it was put in the ground, and you can see the temperatures cool off quite quickly. So what we want to do here is just get rid of all this data here that doesn't represent conditions in the ground. And like I say, this could also be sensor dropouts that go down to unrealistic value. They could be little spikes that just represent something going wrong with the sensor, and it's good to clean those up. And sometimes the easiest way to do that is kind of a semi-automated approach, so you don't accidentally delete data that's representing something real. So what we'll do here is just use the cursor to draw around the points that we're interested in, and that changes their color. They're a darker blue now, and so we can either replace them if we're using something like -999 for a no data value, or just delete them entirely. Now, the other way that you can filter or identify data that might be a little bit suspicious is using this library of filters. Right now there's only 4, but it's easy to add more, and development is ongoing to add more statistical based filters. So for now we'll just go with a minimum threshold value, and so we can, for demonstration, just choose a value like -4 and click on it, hit apply, and then anything that's below -4 will get highlighted. And obviously something like -40 would be more appropriate to be able to detect inappropriate values. Similarly, once again, you have them filtered, so they turn red. You can select the filtered data and then either replace it with something like -999 or just delete it. And then maybe we'll delete that too. So now we have our sort of what's left of our data set here, and we can export the changes into a variety of formats. Like I said, the TSP library does the file input-output, so we can use any of the formats that are present in that library. I'll save it as a GNTP database file. So I'll just put it in this output here, example file. And so it successfully exports it as a GTNP file. So if you can use this as a way to gather up your logger data and submit it to somewhere like the GTNP database. So as an example of that, with a file with some more data, we can look at this GeoPrecision file that I happen to have on hand here. And so here again, you can see there's a bit of a discontinuity here between when the sensor is in storage or in transit and when it gets deployed into a borehole. So we can, again, just using the interactive tool here, pick out the data that's not really representative of our site conditions and just get rid of it. And then save that. Depending on what you're doing with it or where you're submitting it to, you can save it as whatever you like. And that's pretty much it. If If you're interested in contributing to the project by adding some more filters or submitting any bug reports, gitlab.com/permafrostnet/tempcf. There's another set of documentation pages here too.